Okay, this is section 2.5. It is on deductive reasoning, and we're going to learn some laws today, some like logic laws, if you will. We talked about inductive reasoning, the very first section of this chapter. Does anybody remember what inductive reasoning is about? We draw conclusions based on, okay, sort of, but based on like patterns. Okay, remember when we were talking about patterns of numbers? So deductive reasoning is the process of reasoning logically and drawing conclusions, or let's say a conclusion, from given facts and statements. Okay, so again, inductive reasoning, we draw conclusions based on patterns. Okay, deductive reasonings, we're drawing conclusions from given facts and statements. Okay, and that's where these logic laws are going to come into play today. So the first one here is the law of detachment. Given a conditional statement, if the hypothesis, now remember the hypothesis is the beginning part, like if we have a conditional statement, if P then Q, P is the hypothesis. So if the hypothesis is true, then we can assume the conclusion is true. Okay, if the hypothesis is true, then the conclusion is true. Now, I've said it before, mathematicians are lazy when it comes to writing, so we will use symbols to reflect anything that we can possibly do and substitute with a symbol. We're going to do it. So remember, our conditional statement looks like if P then Q, or P implies Q, that's what that arrow means. Then we can say, if P is true, then I'm throwing out all these math symbols today. Okay, it's kind of like a math problem, some kind of big equation kind of thing here. So if P then Q, and then the next step is P is true, therefore, these three dots are therefore Q. Okay, so if you set up the statement, if P then Q, or P implies Q, okay, then you say P's true, therefore Q has to be true. Okay, so that's the three triangle dots essentially mean therefore. So look at the directions here. Use the law of detachment to give a valid conclusion. If not possible, write no valid conclusion. If Mark saves $30, then he can buy a new video game. Mark saves $30. So what conclusion can we draw? He can buy a new video game. Okay, it literally is that straightforward. Okay, they give us the conditional statement, if P then Q. We're told that P is true, so then we can conclude that Q is true. Okay, if a quadrilateral is a rhombus, then it is also a parallelogram. Quadrilateral ABCD is a rhombus, so then what can we conclude? ABCD is a parallelogram. You got it. But and I probably should have said quadrilateral ABCD is a parallelogram, but you get the idea. Next one, if you are 18 years old, then you can register to vote. Olivia is not 18 years old. Okay, so let's think back here a minute. Did they tell us that if we have a not P, that implies a not Q? No. All the original law of detachment said that if we're told that P is true, then we can say Q is true. Well, this one down here says not P. Okay, Olivia is not 18 years old. No valid conclusion. We don't know anything from that. Okay? It's tempting to say that she cannot register to vote, okay? Which actually, if truth be known, you can actually register when you're 17 and a half. It doesn't kick in until you're 18. But so we cannot draw any valid conclusion just based on that statement because that doesn't fit the rules. Okay, P has to be true for us to conclude Q. Okay, number 4, if the sum of the measures of two angles is 90 degrees, then they are complementary. Measure of angle J is 58 degrees and measure of angle K is 32 degrees. What can we conclude there? Why would measure of angle J and measure of angle K be complementary? Because 58 plus 32 equals 90 degrees. So yes, we can say that measure of angle J and measure of angle K, or actually I don't need the measures. Let me back up, sorry. Just angle J and angle K are complementary. Are we okay with that? Okay. Number 5, if you plan to attend prom, then you must purchase a ticket. Sarah purchases a ticket. Okay, Layla just said the Q is true, not the P. Does that fit the law of detachment in any way? No, law of detachment says if we have if P, then Q, and if we're told that P's true, then Q's true. This, in this case, you plan to attend prom, that's your P, that's your hypothesis, okay? You must purchase a ticket, that's your Q, that's your conclusion. So purchases a prom ticket here, that's actually the Q. This is no valid conclusion. It does not fit the formula, if you will, okay? We don't have anything that says if Q is true, then we can do the converse and P is true, okay? Okay, now let's switch from law of detachment to law of syllogism. The law of syllogism allows you to draw a conclusion from two conditional statements in which the conclusion, whoops, would help if I could write properly, in which the conclusion of the first statement is the hypothesis of the second statement. Okay, the conclusion of the first is the hypothesis of the second. And again, the symbolic map here, okay, that's what we did on the front side with law of detachment. With law of syllogism, this says if we have if P then Q, then we're given if Q then R, we can therefore say if P then R. Now, let me give you kind of a high level example. Just off the top of my head. If I have the money, then I'm going to the store. If I go to the store, I'm going to buy a CD. I know I'm dating myself. Okay? So then if I say I have the money, what can you conclude? I'm going to buy a CD. Okay? So it's almost as if these Q's kind of cancel each other out. The Q from the first one, the conclusion from the first one kind of cancels out the hypothesis from the second one, and you can go straight from P to R. Okay? I also kind of like to write it P to Q, Q to R, so we cut out the middleman and just go straight from P to R. Does that make sense? Okay, that's kind of what we're doing. Okay? So, use the law of syllogism to give a valid conclusion. If not possible, again, write no valid conclusion. If it is Saturday, then Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack his lunch. So what conclusion can we make from that? If it is Saturday, then Jake will need to pack his lunch. Okay? So again, Jake has a baseball tournament, and Jake has a baseball tournament, those kind of cancel each other out, if you will. Okay, we go straight from if it is Saturday, then Jake will need to pack his lunch. Everybody okay with that? Again, kind of just cutting out the middleman, if you will. The next one, if a number is divisible by 12, then it is divisible by 6. If a number is divisible by 6, then it is divisible by 3. So what conclusion can we make? If a number is divisible by 12, then it is divisible by 3. Again, that it is divisible by 6, those kind of cancel each other out, if you will. So we have, if a number is divisible by 12, then it is divisible by 3. Way too much writing for a math person. Okay, let's look at the next one. Actually, I want to jump down to 9. For the sake of time, I'm not going to do all of these. But if it is sunny this weekend, then you will go boating. If it is sunny this weekend, then you will wear shorts. No valid conclusion. Again, the reason being, this does not match this. Okay? Those are not a match. Okay? I'm going to throw like a not equal to, not a match, so no valid conclusion. Number 10, if you shop at Target, then you will use your Target red card. If you do not use your Target red card, then you will not get 5% off. Good, no valid conclusion. Again, reason being here, you will use your Target red card. You do not use your Target red card. Again, not the same thing. Those are not equal, so no valid conclusion again. Okay. Last one. If it snows, then school will be canceled. If school is canceled, then students will need to make up a day of school. Okay, sorry. If it snows, then students will need to make up a day of school. Again, school will be canceled. School is canceled. Those are the same thing. They kind of, again, cancel each other out, if you will. So if it snows, then students will need to make up a day of school. Okay. All right, let's look at the next page. Now, again, the symbolic map here of law of detachment. Just want to touch it one more time here. P implies Q. Again, this is if P, then Q. P implies Q. P is true. Therefore, Q must be true. Okay? On the law of syllogism, again, same thing here, but we have P implies Q, and then Q implies R, so therefore, P implies R. Okay? We kind of, again, skip the middleman, so to speak. Okay, so now we're going to be reading some statements and determining, it says, determine whether the conclusion following the given statements is justified by the law of detachment or the law of syllogism. If neither, write invalid. So we're actually identifying, okay, which one it is, or saying it's neither, and they're off the rocker. Okay, number 1, if I drive over the speed limit, then I will get a ticket. I drove over the speed limit, so the conclusion is I got a ticket. That is the law of detachment. Again, law of detachment. P implies Q. P is true, so Q is true. Number 2, if Amanda goes to the restaurant, then she will order a hamburger. If she orders a hamburger, then she will get fries. So the conclusion is, if Amanda goes to the restaurant, then she will get fries. Law of syllogism. And try not to say that fast 5 times. If Amanda, well, we'll just, yeah. I, for a minute there, thought I had to recopy. Law of syllogism. If Amanda goes to the restaurant, then she will get fries. Number 3, if it snows, then I will wear my snow boots. If it snows, then I will not go to school that day. If I do not go to school, then I will wear my snow boots. Invalid. Good. Okay, it kind of lends itself to syllogism, but obviously it doesn't match up because the only 2 things that match are, yeah, the 2 hypotheses, not the conclusion and hypothesis. Okay, so invalid. Number 4, if Tina goes to the beach, she will wear sunscreen. Given Tina goes to the beach. So the conclusion is Tina will wear sunscreen. Yeah, law of detachment. Number 5, if you get a cold, then you eat chicken soup. You ate chicken soup. Conclusion, you must have a cold. Invalid. Why? Yeah, they switched the P and Q. Okay, again, for the law of detachment, if P's Q, then we can conclude Q. But they gave us Q first, so invalid. Okay, last one on the front here. If 2 angles form a linear pair, then they are supplementary. If 2 angles are supplementary, then the sum of their measures is 180 degrees. So the conclusion is if 2 angles form a linear pair, then the sum of their measures is 180 degrees. Law of syllogism. Again, these 2 match, so we can kind of cancel them out. Okay, backside. If 2 angles measure 60 degrees, then they are congruent. We're given that angle J is congruent to angle K. So the conclusion is that the measure of angle J is 60 degrees and the measure of angle K is 60 degrees. Okay, I'm going with the invalid. Why? Yeah, this is another example of they kind of flip-flop the P and Q. Okay, so this is your P. 2 angles measure 60 degrees. They are congruent is your Q. What they gave you here was the Q. Okay, well then we can't necessarily conclude the P. We can't go backwards, so that's invalid. If Kaylee gets at least a 95 on her final exam, then she will get an A in geometry. Kaylee got a 98 on her final exam, so the conclusion is that Kaylee got an A in geometry. Definitely law of detachment. Okay. And number 9, if it is raining, then you must bring an umbrella. You bring an umbrella is the given, so the conclusion is it is raining. Invalid. Again, they switched, right? So once again, this is my P, this is my Q. They gave me the Q. I cannot conclude the P. Okay. Now, number 10 here, we're working from several different statements. It says, use the law of syllogism to write 4 conditional statements that can be formed from the following true statements. Okay, so assume all of these 6, A through F, are true. And we need to use the law of syllogism to write 4 more conditional statements based on these. So, for example, good. So A and D comes together, right? Again, you're looking for it has 4 right angles as the Q of one to being has 4 right angles as the P of the other. So what would my statement 1 be then, using A and D together? Good. If a quadrilateral is a square, then it is a rectangle. And that is true. Every square is also a rectangle. For that matter, every square is also a rhombus. But okay. Okay, B and, what did you say? B and F, let's look at those two together. So B and F, so again, we've got its opposite sides are parallel, and then we start F with opposite sides of a quadrilateral are parallel. So definitely, what statement here, statement 2, could we make from B and F together? If a quadrilateral is a rhombus, then it is a parallelogram. Okay. Are we okay with those two? Somebody see another one? D and E, okay. So D and E, D has, it is a rectangle, and E starts with, if a quadrilateral is a rectangle, so we can definitely combine D and E. What would that give me as a statement? If a quadrilateral has 4 right angles, then its opposite sides are congruent. Yep. Okay. Anybody see another one? We need one more. So this was A and D. Let me write these. This was A and D. This was B and F. The next one was D and E. Ooh, F and C, but we have to go the other way. I thought I heard somebody say that earlier, didn't I? Did I not? Okay. I just imagined it. So think about this one kind of in reverse order, if you will. Okay, F and C, it is a parallelogram, matches with quadrilateral is a parallelogram. Okay, so the F has to come before the C. I'm going to run out of room here. You guys have it on your papers. But so how would I start this? This is F and C. Good. If the opposite sides of a quadrilateral are, okay, I'm tired of writing. I'm going to use the symbol for parallel. Do you all remember that symbol for parallel? 2 vertical bars. Okay. If the opposite sides of a quadrilateral are parallel, then its opposite sides are congruent. I'm really being lazy because I'm also going to use the symbol for congruent. True mathematician, I'll use symbols over words any day. Yes, good catch. I wrote sides and it should absolutely be angles. So it does say angles. Okay, if the opposite sides of a quadrilateral are parallel, then its opposite angles are congruent. Good. Any questions on law of detachment, law of syllogism? It's really quite straightforward. Okay, enough of this.